tutorial is for 4th grade, Module 6, Lesson 4. In this lesson, we're going to use centimeters and meters to help us understand the hundredths place in decimals. The first question says, how many centimeters make a meter? Well, it takes 100 centimeters to equal 1 meter. Part B asks, what fraction of a meter is 1 centimeter? Well, if I have 1 centimeter out of the 100 that it takes to make a meter, 1 centimeter is considered 1/100th of a meter. Question 2 says, what is the length of the shaded part of the meter stick in centimeters? So my whole bar here is considered 1 meter. It has been divided into 100 pieces. Each little piece represents 1 centimeter. If I look at the shaded portion, I can see that there are 4 pieces shaded in. That means there are 4 centimeters shaded in on the meter diagram. In fraction form, this would be 4 out of 100. In decimal form, I have a 0 in my ones place. I have a 0 in my tenths place because I don't have any full tenths shaded in. And I have a 4 in my hundredths place. The second place to the right of the decimal point is my hundredths place. So as a decimal, 4 hundredths is written as 0.04. Let's look at the next question. This one says, again, what is the length of the shaded part of the meter stick in centimeters? Again, I have my full meter stick. This time I have 10 of the little sections shaded in, so that would be 10 centimeters. In fraction form, we would show the length that is shaded in as 10 out of 100. Now, to write this in decimal form, let's review our places here. So we have a 0 for a ones place. The next place is our tenths place, and then the second place over is our hundredths place. Well, I have 10 hundredths, but I can't write 10 in one place value spot. Instead, what I need to do is write the 10 so that it lands in the hundredths place. And you can see that this makes sense because now I have a 1 in my tenths place. Each of these sections on my meter diagram is 1/10. So you can see here that 10 hundredths is the same thing as 1/10. And we'll write it in decimal format then, 0.10. In problem 4, I have a meter that's been divided into 10 equal pieces. Question A says, in fraction form, express the length of the shaded portion. So here I have 1 piece that's shaded out of the 10 that make up the meter. So this is 1/10. In decimal form, we would write that as 0.1 because that's 1/10. Question 5 says, what do you notice about the shaded portion of problem 3 compared to the shaded portion of problem 4? So if we go back and look at problem 3, as we mentioned, 1/10 has been shaded in on the whole meter. That 1/10 was made up of 10 hundredths. So if I go back to problem 5, I can say that 10 hundredths is equal to 1/10. And now we can show that comparison. In word form, we would say 10 hundredths is equal to 1/10. In fraction form, we can show that 10 hundredths of a meter is equal to 1/10 of a meter. And in decimal form, we'll show that, again, 10 hundredths is the same thing as 1/10. In question 6, we're looking at a model that's showing both a tenth shaded in and some hundredths. The directions say to use the model to add the shaded parts to show the decimal form, and then we'll write a number bond with the total written in decimal form. So we have our meter diagram, and you can see that here I have 1/10 of the meter filled in, and then in the next section I have 3/100ths. So we'll write that in fraction form here. So we have 1/10 meter plus 3/100ths of a meter in decimal form equals 0 and 1/10 and 3/100ths, or another way we can say that is 13/100ths of a meter. The number bond has been filled in for us, so we have 1/10 represented by the 1 in the tenths place, and 3/100ths represented by the 3 in the hundredths place. Let's look at problem B. In B, I see that I have 2/10ths shaded in, so I'll write that in fraction form. So we have 2/10ths, and then I have 4/100ths. So we'll write both of those numbers in decimal format. I don't have any whole meters shaded in, but I have 2/10ths and I have 4/100ths. We can write that as our number bond. We'll start by writing it in decimal form. And then the 2 means that we have 2/10ths, and the 4 means that we have 4/100ths. I started this question by shading in 19/100ths. My meter has been broken into 100 little pieces. Each one of those was 1/100th, and I shaded in 19 of those. To write that in decimal format, I would write that I have 0 whole meters and I have 19/100ths. Now what you can see is that we can compose 10 of those hundredths into 1/10, because it takes 10 of these pieces to make the entire meter. So 19/100ths can also be considered as 1/10 and 9/100ths. Here's my 1/10, and here's my extra 9/100ths. And again, as a decimal, we would say that 19/100ths is the same thing as 1/10 plus 9/100ths. And again, we'll show the connection between fractions and decimals using number bonds. I have 19/100ths written as a fraction. I'll start by writing it as a decimal, and we'll put that decimal in the number bond. And now we'll show that the 1 in the number represents 1/10, and the 9 in the number represents 9/100ths. Do the same thing for part B. Here I have 28/100ths. I'll write it first as a decimal, and then put that into my number bond. In this number, the 2 represents 2/10ths, and the 8 represents 8/100ths.